you have sine of z, cosine of z, and tangent of z. You are not using the calculator at all. So this is like a little warm up, freshen up your brains. Your z, because there's no angle, we're not doing any math. You're just writing the fraction that would represent sine of z, cosine of z, and tangent of z. So figure out which one's your hypotenuse. Figure out which one's the opposite of you and adjacent, and then just write the fraction. So, Toa.
Sokotoa. No, you are Sokotoa.
Ava, go to class. Huh? Well, go to lunch.
No.
You're not hanging out here. Go to lunch or go wherever. Go somewhere else. Find a home.
I really like your outfit.
That is sparkly.
It's so fun. Oh, sorry. I was like that with. I forgot. I forgot. Yes, I want to make a friend so bad. She was my room, so she's like really good. She goes, yeah.
So what is sine of z?
21.
Good. Opposite over hypotenuse. So 21 over 35. Cosine of z would be what? Adjacent over hypotenuse, which is 28 over 35. Tangent is going to be what?
21.
21 over 28, because it's opposite over adjacent. Okay. Let's talk about the new stuff. The new stuff is angles of elevation and angles of depression. So you got two pictures. What we're going to do, it says you're going to do a personal observation. We're going to use the two photos above to, in your own words, explain. You're going to make a little hypothesis, okay? Explaining the difference between an angle of elevation and angle of depression. So when you're looking at this, your angle of elevation is right here. It's in the little triangle. Angle of elevation, it's a little cut off. This one is your angle of depression. So take a second and just think about what the difference is, because they are not the same. They are different from each other. So in your own words, take a second, describe the difference between them. A hypothesis, a conjecture, science class. It's all right, you'll survive.
I've been really good with.
You're bad at algebra?
Yeah.
I love algebra. Like quadratic,
I'm good at
exponential function.
Actually, I only remember why because I went to me and I don't even remember.
That's like not even algebra. That's like free algebra.
Yeah, I still don't know how to solve it.
Oh, what?
Like I knew how to solve it, but like if you were to give me like a while, I don't think I could.
Oh my gosh. I'm gonna pray to the math gods for you. Okay. So what's the difference? Can anybody explain the difference between an angle of what's an angle of elevation doing? It's going up. Okay. So you have a line of sight. So that's like you looking straight, and then you go outside and you see a pretty bird. So then you look up at the sky. That's an elevation. It's going up. Depression is like all of us right now because we have word problems. We're all depressed. Okay. This is when you're up high and you're looking straight, and then you look down at something like the dirt's on the ground. Okay. So depression's going down. So what we're going to do, we're going to draw a picture for each situation using trigonomic ratios to solve for the unknown. We're going to round to the nearest tenth if needed, which is 1 decimal place. So here we go. When in doubt, we're going to draw it out. So the angle of elevation from a yacht to the top of a cliff is 18 degrees. So first off, is my angle going up or is it going down? It's going up, okay? If the yacht is 300 feet from the base of the cliff, determine the height of the cliff. And you're like, what the heck? So we're going to draw it out. So we're getting crafty. Here's a cliff. Here's a yacht. Okay. All of these pictures are going to make a right triangle out of them. So even though you have a yacht and you have a cliff, this is forming a right angle right here and right here. So you have your 90 degrees still in your corner. And then where you connect the cliff to the boat represents the hypotenuse of the triangle. So if the angle of elevation from the yacht to the cliff is 18 degrees, I already have a 90 degrees. Would 18 degrees go at the top of the triangle or at the bottom? It's at the bottom because you're on the yacht and you're looking up at the top of the cliff. So 18 is going to go here. How'd it go? Was it a success? Okay, good. If the yacht, so your degrees always goes inside your triangle. If the yacht is 300 feet from the base of the cliff, where would 300 go? The base, because the boat is 300 feet from the base, meaning the bottom of the cliff. So 300 is going to go here. And then I need to determine the height of the cliff. So would that represent the hypotenuse or the other side of the triangle? The other side, because I want to know the height of the cliff or how tall the cliff is. So the math is exactly the same from the past 2 days. So if you are the 19, is this sine, cosine, or tangent? This is tangent. Because I do not have a hypotenuse. I have an opposite and I have an adjacent. So tan of 18 equals opposite over adjacent. So it's the fraction 300 over x or x over 300? X over 300. So take a second. The math is exactly the same. You're going to put it over 1 and you're going to cross multiply like a beautiful butterfly. So you should be doing 300 multiplied by 18 tangent. What is it? Yeah. So you should get 97.5. Is that what we got?
Yeah.
Okay, nice. So this one did not have the extra step. It was just like cross multiply, multiply, so 97.5. Okay. Okay, let's do number 2. Number 2 says a pilot of a rescue helicopter spots a lost swimmer in distress at an angle of depression of 12 degrees. If the helicopter is at an altitude of 100 meters, determine the distance of the helicopter to the swimmer. So let's first draw our picture. We have a helicopter.
Wow, it's
That's my helicopter. Okay, okay. So when you spot, think about it, if this person is in a helicopter and they spot a distressed swimmer, so somebody like drowning, okay, they need help, are they directly underneath them or are they off in the distance? They're off in the distance. So they notice them, they're all the way over here because they're like, help, because I'm dying, I'm drowning. Okay, so there I am. I'm making a right triangle out of this. You're always going to have a perpendicular line because it's creating a 90-degree angle. So from my helicopter to the ground, or not the ground, but the water, I have a right angle every single time. And then connecting from the helicopter to my person is going to represent the hypotenuse, which is the distance between them. Whatever. And then we got to put the number somewhere. So let's go back to the problem. It says a pilot of a rescue helicopter spots a lost swimmer in the distress at a depression angle of 12 degrees. So depression, is that increase or decrease? And this is where it gets a little weird, okay? So technically you have your line of sight. So whenever I'm flying my helicopter, I'm looking straight. My angle of depression goes from my line of sight down. So it's actually this angle right here. So 12 degrees is here, okay? It's on the outside of the triangle, but it's okay. It's okay. This involves chapter 3 stuff, which is over here on this poster. Parallel lines cut by a transversal, where you have 2 lines crossed by transversal. So these are your parallel lines. You have your line of sight, and you also have the water where the guy's drowning. Those are your parallel lines. This is your transversal that would be cutting through them. Okay. So 12 degrees can go in one other spot. Can it go next to it? Or would it be able to jump across the transversal and go down? Do you know what that's like called? What that vocabulary word is? Like why I can move the 12 here because it can go down.
No, it's on the same.
Well, we have the parallel lines, the transversal. These are alternate interior angles. So they can jump across the transversal alternate interior angles, make them congruent. because this corner would not also be 12 because this section would have to add to make 90. If this is 90 degrees, this is also making a 90-degree angle, okay? So 12 degrees can jump across the transversal and end up down here. A lot of people where people mess up is they're going to put the 12 up here because they're like, I'm looking down, so it's there, but that's not right. Oh, degrees always go inside the triangle, except for that case, I mean, but it's an angle. So, okay. If the helicopter is at an altitude of 100, where's 100 going to go? This side? This side? This side? This side? Yeah, because it's the altitude, which is the height. Okay, so 100 goes there. We need to determine the distance from the helicopter to the swimmer. So am I putting X at the bottom or am I putting X on the hypotenuse? Hypotenuse, because I want to know the distance between the helicopter and the person who's drowning. So SOHCAHTOA, sine, cosine, tangent. If I am the person, I'm at the 18 degrees, what am I going to use? Sine, because you have an opposite from the 12 and then you have the hypotenuse. So O and H is going to be sine. So we're going to do sine of 12 equals 100 over X. So take a second. We're going to put it over 1. We're going to cross multiply. Close, but not close enough. What is it? Yeah, 481. The reason why is because this goes over 1. If I cross multiply, this is X times sine of 12. So this is not a multiplication problem. I'm going to have to do that extra step and divide. So you're taking 100 in your calculator and you're dividing by 12 sine. And then whenever you round, so 100 divided by 12 sine, and you press equals, this is 480.97. The 7 is going to make the 9 go up to a 10. The 10 is going to make it go up to a 1. I thought you said 480. Yeah, that's not right.
What?
The EOC is going to be like, you're wrong.
Basically.
It's not though. So 481. So you do need to know how to round for these ones because these are the ones that they will put on the EOC and say like round to the nearest 10th and it won't be multiple choice. So you need to make sure you know how to round. Rounding goes back to like what freaking elementary school. Yeah, it should be like back in the day, like way back when. But I would say there's like 20% of you that do not know how to round. Probably more. I'm like 30. So I'll trade up Pythagoras for you and whoever invented rounding. Okay, let's try number 3. So take a minute. Got this. I'm believing you. When in doubt, draw it out. Remember, you can't climb a ladder straight up vertical because you would fall backwards. You're leaning a ladder up against the wall. Did you take that pen out of my bag?
Determine the length.
Oh, let me try to back sense.
I know it's deep.
It is cute. I gotta play when I get to Evelyn. Don't like it.
I was just looking at some and I found them.
So it doesn't work nice. It's very nice. So this is like that. I assumed it was gonna be crap. Oh, I assumed it was gonna be bad, so I figured I just this.
All right, so I don't get subscribed to this stuff. Angles of the that makes it a 1. Right, so the 5.
Okay, so there's your picture. There's my wall. My ladder is leaning against the wall. The ladder rests against the wall. The base of the ladder is 4 feet from the wall. So where's 4 going? On the bottom, the base. Good. Context clues. If the angle of elevation from the ground is 52, where's that going to go? No. At the bottom. Because it's angle of elevation from the ground. You're on the ground, you're going up. Because it's elevation. You're going up. Okay. Determine the length of the ladder. Where's X going?
X is going under the wall. The one.
The hypotenuse. So you should be using cosine.
Should probably the lamp in here.
A lamp?
Yeah,
Do you want me to turn on the lights?
turn off the lights.
Oh, you what?
You should get a lamp so you can turn off the big lights. So it's really bright and it's loud.
It's not even bright. I only have half of them on.
It's
I don't even know where the spotlights are on.
it's just that one. It's that's the where's the spot? Oh, it's in the spotlight.
Just keep the spotlight.
Oh yeah, the spotlights.
The lights, just keep the spotlight. Yes.
Yeah.
Like this.
It's nice and homey.
My spirit by room. I like how it shines on us.
Okay, so what do we end up getting for our ladder?
It's about that.
6.5. So this one had the extra step you had to divide. So make sure you're careful. Okay, try number 4. When in doubt, draw it out. You got this. I believe in you. You can do it.
Depression. All right.
Depression, because we're sad.
Lighthouse. I put the lighthouse light. Depression. So shit.
It's also losing for the lighthouse. That was once back.
But no, able to this part makes sense.
It's how that's a really nice lighthouse.
Thanks.
Better than my lighthouse. My lighthouse kind of looks like the one when I was like 16.
I kind of just put the light part of the lighthouse. I put a circle with a dot in it.
Oh, I should probably add a dot. There's the light.
They're not perfect.
Kind of looks like a. Oh,
Yeah.
It looks like it's physical. To me, with like a ring on it.
18.
So it's three of us. Yeah. You get it?
Yeah.
You get it.
Yeah.
55 meters past that. So would that be on the side? Right.
Mhm.
Angle of the depression.
No.
So is it between?
So you have your line of sight and then it's going down. So it's actually on the outside of the triangle. Mhm.
Yes.
So it's on 18. So, yeah, so it's on.
Bless you.
How is it 160?
I don't know, is it?
Yes.
Okay, so where does the 55 go on my picture?
It goes on the height.
The height of the lighthouse, so 55 is here. And then it says an angle of depression is 18. So this is like the weirdo where you're technically looking straight. The depression's on the outside, so it does not go on the inside top corner. It moves because alternate interior angles, so it's going to move down here. And then it says, if the foot of the lighthouse is at sea level, how far is the ship from the base of the lighthouse? Where's X going? No, the base.
Short.
Okay, so this should be a tangent problem.
Now this is confusing.
And then it's opposite, which is 55 over adjacent, which is X. So this one, because your X is in your denominator, you're gonna put it over 1, you're gonna cross multiply, and you're gonna divide. But you're not using this 18, you're using this 18. The one that's inside.
It's 55. It's the 55 for it.
Huh? No, it's opposite over adjacent. Or am I wrong?
So
TOA. Like look at your it's opposite over adjacent.
that's I think I'm
Wait, is 95 code?
I found something else about it. Elevation goes up, so you're at the bottom and you're looking up.
Look up in the air.
Yeah, the person's looking up.
Uh,
But it's still like your line of sight's this way and you're looking up at your kite, so it's inside the triangle.
in the park.
So what do you end up getting for number 4?
What's 69.2?
0.3. You're wrong.
What?
It's at
Spirit.
42.
Oh my gosh.
You gotta learn around.
Oh my gosh.
We're gonna skip the reflection part.
We're gonna start like,
Try number 5, last one.
How we doing it back?
Heck yeah.
wait.
Huh.
So, this is the first time in like forever. Would you press EX? And I don't believe these.
No.
Okay, oh,
Yes.
yes.
So when in doubt, draw it out.
So angle of elevation. Oh, stop. With string, oh. I got it, okay, I got it. So would the string be the long side? Cause those kites fly like.
Because when you fly a kite, it doesn't go straight above you. Off to the side. My daughter loves flying kites. She was flying a kite like 2 days ago. Go run, go. You never flown a kite?
I used to like have 3 kites in my house and I always been calling the electrical one.
Why are you flying a kite inside the house? Oh, like outside?
Yeah.
Yeah, I just tell Evelyn to like go to the cul-de-sac, and she just like runs in circles with it. And I'm like, yeah, go. Wear yourself outside.
It's sunny, right?
There are sunny.
No. This is not sign. What is this? Does anybody know?
Wait, we're not doing the last.
The last one's a reflection. It's not a word problem. So a kite with a string of 75 feet is flown. So where's 75 going? The hypotenuse, because it's the string of the kite. The angle of elevation is 45. So where is that going?
Is it not in the
That's going at the
angle?
very end.
Is it over here?
No,
It's
the
at the
bottom
bottom.
angle.
Yes. The key is, honestly, this is like the cheat system. Elevation's always going to be in the bottom corner. Depression's always going to end up also in the bottom corner because it's always on the outside and you have to flip it inside to the bottom corner. So your angle's always going to end up in the bottom corner. Determine how high the kite is in the sky. So where's X going to go? Oh, it is sign. Oh, I'm looking at the back. My bad. Because there's a kite problem on the back. This is sign. I'm sorry. My bad. So 45. My bad. Yeah.
I'm very stressed.
Clearly.
So is it just 53?
Yes.
Great.
Because it ends up being like 53.0 something.
Yeah, 0.03. So no round.
So there are problems on the back. I drew the pictures for you, so you don't have to do that. Some of them also already have the numbers on there. Some of them do not, and you have to put the numbers on the picture, okay? So what I need you to do first is finish your paper from yesterday and turn that in. So this is where you have time to do it. And then you can work on your problems. The back looks like a lot. It's not a lot, I promise. Okay. If you get done with this paper and you want me to check your answers, you can bring it over here. I'll mark you off so that way it's finished and I'll have to correct it tomorrow. Your other sheet from yesterday is being turned into the bin. Today's is not being turned in.